Hello. Yesterday we were doing some cases for dipole moment, and we were doing sorry, not dipole moment. We were doing uh, one of those topics like we wanted to find the potential for the dipole moment, for a dipole, for a quadrupole, and so on and so forth. So today we are going to continue with the same. Okay. So this is in the series of Legendre's polynomial only that we are studying. Uh, and yesterday we were trying to find the potential due to specific arrangements. Like for example. We were trying to find the first we tried to find the uh, potential due to a charge placed at 0 comma 0 comma a at a distance r where r is less than a. Then we also tried to find the potential due to charge q placed at 0 comma 0 comma a such that the sought point is at a distance small r and that small r is greater than a. Then we also this was a kind of monopole we got the potential of the monopole. And we found that the leading term of this potential due to monopole is directly proportional to 1 over r. Okay. So an electric dipole, as you might have studied in standard 12, consists of two equally and opposite charges. So there are two equal and opposite charges separated by a distance 2a. Let us take that as 2a. And if this is 2a and this charge is q and this charge is minus q placed here, then potential due to at any such point p, which is at a distance small r and r greater than a. So we were focusing on the solutions where r is greater than a, and we were trying to find the asymptotic variations. That is, we wanted to find that at a very large distance, what would be the leading behavior. Okay, so this is another thing that we were doing. And then today we are going to continue from here only. And then we also tried to uh, find what is the potential due to a quadrupole arrangement. So we made a linear quadrupole arrangement. And in this linear quadrupole arrangement, we had a charge q at 0 comma 0 comma minus a and other charge at 0 comma 0 comma a and minus q. So basically, what is a quadrupole? You can say that quadrupole contains, if you really see the, like, if you see what, like, just give me a minute. Okay. So if you see, you can write this particular arrangement as like charge q is placed here at 0 comma 0 comma minus a. Another charge q is placed here at 0 comma 0 comma a. And then you have a charge at center, which is minus 2q, which is 0 comma 0 comma 0. Okay. So if this is so if you just join them up and if you just write it as minus q and minus q, and here you have q, here you have q. So basically there is a dipole moment. And if you remember from your standard 12th class, the dipole moment always uh, has a direction from negative charge to positive charge. So there are two equal, like two opposing dipoles. So two opposing dipoles are here. So this kind of arrangement is called as quadrupole. This kind of arrangement is called as your. This kind of arrangement is called as your quadrupole arrangement. So here in this quadrupole arrangement, okay, in this quadrupole arrangement, you have two dipoles, right? So two dipoles are here. So instead of minus 2q, you can write minus q. And this is minus q, this is q here, this is minus q, this is q here. So this is how your dipole is. Like there are two dipoles here. Okay. This kind of arrangement is called as the linear dipole. Okay. So this kind of arrangement is called linear quadrupole. So linear quadrupole arrangement was given by this. And we found that potential at any point, potential at any point P, potential at any point P is given by 2q upon 4 pi epsilon naught r summation n equal to 0 to infinity. And we found that only even terms would survive. Okay, here we found that only linear even terms would survive. In the previous case, we found that only odd terms would survive. That is a upon r ki power 2n plus 1, and here you had p2n plus 1 cos theta. Similarly, today we are going to do something called as linear octupole arrangement. And linear octupole arrangement is given by, this is a sort of linear octupole arrangement. And let us try to find what will be the potential due to this linear octupole arrangement at any point small r this like any point P which is at a distance small r from the origin. So let us try to do that. Okay. So okay, so let us do this. So this is my linear octupoles. I have written at minus 2a, I had minus q. At minus a, sorry, I'll write minus a here. I had this minus 2q. And then I had this origin 0, 0. And then I had this at a, at point A, I had this again minus 2q. And again at 2a, I had this q. Oh, sorry, there would be a mistake here. So this cannot be the case, sorry. Okay. And here I had this charge. Okay. Okay. So this is known as your linear octupole arrangement. So this is called as your linear octupole. So here you have a linear octupole arrangement. So if in this arrangement, let us take a point P at a distance r. Okay. At a distance r. And we want to find what is the potential at this point. And you can take it at very far away distance. And this is theta. And we have used law of cosines quite often now. So this distance is a, this distance is r, this is theta. So we can know what is this distance. So I'll start writing with, so potential at P. So potential at P due to this, let's say, and you can take it as very far away. Like we want to discuss the cases only if r is greater than a. So we are focusing on r greater than a. That is, we are talking of very large distances. Okay, or we are concerned about asymptotic cases. So what would be potential at P? So potential at P will be K, Q, and this distance. What will this distance be? This distance would be, if I take this as 2a, and if I'm taking this as RA, so this will be equal to root over R square plus 2a ka whole square, and then you have minus 4AR cosine theta. So this is it. What would be this distance then? So I know this is theta, this would be pi minus theta. So if this is pi minus theta, this is R, this is 2a. So this will be minus KQ divided by root over R square. And then you have this 2a ka whole square. And then I can write one more thing plus 4AR cosine theta. Similarly, if I go ahead and if I take this charge, so this charge, this is theta. So, sorry, this charge, if I take first, let us take this charge. This is theta. This is minus 2q. This is r. This is a. So this distance would be root over a square plus r square minus 2ar cos theta. So what I'll do, I'll simply write minus k into 2q divided by root over r square plus a square minus 2ar cos theta, and then plus again k into 2q, and then again root over r square plus a square plus 2ar cos theta. So these are all such things that we've written, and we want to write what is the potential in more concise form. So I'll write, so I'll simply write q upon 4 pi epsilon naught. And the first term, I'll take r common out. So I'll take r common out, r square common out. So here you will get r. And then you can see this, the first term is equals to 1 plus 2a upon r whole square minus 4a upon r cosine theta की power minus half minus And then again you have this term minus 2, and this is 1 plus a upon r minus, sorry, so this is 1 plus 2 upon r ka whole square minus, what has happened, I think this is minus 4 upon r cos theta, and this is like negative, and then you have minus 2. I should write here, right? No, here. So if I take r common from here, so I'll get a by r का whole square, and then minus a upon r cos theta is की power minus up, and then you have plus 2, and then I will write a by r okay. So Bharat has joined, so let me revise what I was doing. So yesterday we were doing some quadrupole arrangements. Quadrupole arrangement, I have explained that this particular thing that we've done already. Today we are going to do linear octupole arrangement. So this is what is known as your linear octupole arrangement. Okay, so this is what is known as your linear octupole arrangement. So in this linear octupole arrangement, what have we done? Because see, here you have like this is, if you take this minus q from here, so this minus q, if I take minus 2q and minus 2q, if you write minus q cube, so there is one dipole in this direction, one dipole. So there are two opposing quadrupoles in this. So these two opposing quadrupoles would form something called as a linear octupole. So yesterday we were doing this only. So yesterday we were doing all these kinds of stuff where we wanted to find potential due to certain arrangements. So certain arrangements, by which I mean some dipoles. So I started with the dipole. Then I started with another case where we had opposing dipoles on the linear line, that is called as a linear quadrupole. So here you have an opposing dipole. You can see minus 2q, you can write minus q minus q. And at any distance p, we wanted to find what is the potential due to this linear quadrupole arrangement. And most specifically, we were quite concerned with we were concerned with like finding the leading term. Okay. And similarly, today we are doing linear octupole arrangement, which was the last problem statement that I gave you. And here we are trying to find what is the potential at point P. So these distances are due to law of cosines, which you know. And this is what I'm doing. And I'll make a very clever use of what you know as the generating function of the Legendre polynomial. So now the potential at point P is going to have q upon 4 pi epsilon naught r, and then you have this term. This term is set. This term would be called as, I'll write summation. So I'll write summation n equal to 0 to infinity, and then you have the first term. If you see very closely, so that term would be pn cos theta into, this is 2a, right? So I'll write pn cos theta into 2a upon r raised to power n. Then again summation n equal to 0 to infinity. I'll write this term all over again, that is 2a upon r raised power n. I think this would be a negative term, right? So this is a negative term because you see this 2a upon r, this is plus here. So instead of plus, you can write minus of 4a upon r. So I'll write minus 2a upon r, minus 2a upon r raised to power n, then I'll write pn cos theta. Then again this term I can write minus 2 times sums n equal to 0 to infinity, and this will be a upon r raised power n, and then this is pn cos theta, and then you have this plus 2 sums n equal to 0 to infinity, and this is a upon r raised to power n, and then pn cos theta. So this is what will make your potential terms. Is that clear? Is there any doubt till now?
No, sir. Sir, you have written 4 individual terms for potential, and then you have combined 2 of them. So we got 3. terms in total, right?
Yeah,
As a Legendre.
right. So because of this, because of this, because of this, and because of this, so individual point charges are there, and total potential will be sum of all this. Like,
Yes, sir.
is that clear? So बस इससे ज़्यादा कुछ नहीं किया, ठीक है? And all I need to do is now is to see how. So I know that if I see this thing, so you can clearly see that in any case this term would survive. This term, like the term that I have written right now, would survive if n is odd. Because if n is even, this term minus 2a upon r, this will become some even powers, and there's a negative sign here. So in any case, this will get subtracted. So even for n being even, this will be this particular term, which I'm right now indicating, will become 0. So only if n is odd, the terms would be non-zero. Okay, the addition would be non-zero. Rather, I should say the addition would be non-zero. Is that clear?
Yes.
So in totality, this will contain only odd terms, and that also 2 times, because this odd minus is here. So if there's odd terms, so minus will become plus. So I'll write n equal to 0 to infinity, and then I'll write p2n plus 1. I should not write this way. I'll इसको आगे वाला bracket लिख लेते 2a upon r की power. I'll write 2n plus 1, and then I'll write p 2n plus 1, and then I have this cos theta. And similarly, the next two, like these two brackets. So what should I do? These two things. Now just see how these things would behave. How these things would behave. So if these things are to be said, how would they behave? So again, you see, यहाँ पे हमने कुछ गलती करी थी. So here it was minus, and here it was again minus. So minus sign would come here. ठीक है, यहाँ पे एक minus sign पे ठीक है, माइनस है, बिकॉज सी हियर a by r cos थीटा है ना, तो यहाँ प्लस है, तो प्लस को लिखो माइनस माइनस. इस तरीके से अगर लिखेंगे, so overall this again, which terms would survive? Only odd terms would survive, because even term this will become positive, and this is
Yes, sir.
equally that negative. So again odd terms would survive, but this will be 4 times sums n equal to 0 to infinity, and I'll write a upon r raised to power n, and then I will write p, sorry, not n, I should write 2n plus 1, and then I'll write p2n plus 1 cos theta. Is that clear? Okay, so if this is the case, then why not try to again simplify this expression? This will become q upon 4 pi epsilon naught r, and let us take a few things common out. So okay, so what should I do? I will take this 2 outside. So I'll take this 2 outside, so that at least things get some way kuch, and this will not be a negative. This will be a negative sign. You see, this is minus now. So overall, this is negative, and this will again become
Yes,
negative.
sir.
So this will be minus here. Okay. So यहाँ पे गलती कर रहा हूँ. बाकी I don't think कहीं पे भी कोई गलती है. एक काम करते हैं. Take this 2 and this is 1. Like 2 की power 2n and this is 1. So at least take this 2 common out. So this will become, I will write 4. So 4 absolutely take common out. So I'm just saying this 2n plus 1 में plus 1 है ना, इससे एक 2 बाहर ले लो. Just take this 2 common. Is that clear or not clear? चलो एक काम करते हैं, मैं ढंग से कर देता
सर पूरी टर्म ले सकते हैं ना?
आप पूरी टर्म भी ले सकते हो, कोई दिक्कत नहीं है ना. So what I'll do, चलो 2 ही कॉमन लेते हैं एक बार. Let us take 2 कॉमन आउट. So अगर 2 कॉमन आउट लेंगे, लेकिन 4 भी ले सकते थे, राइट? So अगर 4 लेते, एक बार 4 ही ले लेते हैं ना, जाने दो. एक बार 4 कॉमन लेके देखते हैं. So if I take a 4 common out, this will become divide by 2.
Yes,
Isn't it? So this will become summation 1 upon 2, and then I have 2 की power 2n plus 1, and I have a upon r की power 2n plus 1, right? So यहाँ से 2 कॉमन ले लिया हमने, एक 2 कॉमन लिया, मतलब 4 कॉमन ले लो, तो क्या होगा, यहाँ डिवाइड बाय 4 हो जाएगा, तो 1/2 हो जाएगा. सो 1/2 अंदर ले लिया, इसको बाहर लिख दिया, सो दैट मतलब सारे टर्म्स एक जैसे दिखने लग जाए मुझे. इज दैट क्लियर? ये चीज समझ में? एंड हियर ये चीज तो क्लियर है ही. दिस इज माइनस n इक्वल टू 0 टू इन्फिनिटी a अपॉन r की पावर 2n plus 1, and then I have p a 2n plus 1. sorry cos theta. Is that clear? यहाँ तक का तो कोई दिक्कत है ही नहीं. Now you see potential at P is Q upon pi epsilon naught R, and you just take one of them, like you just take इसको common out. So n equal to 0 to infinity, and you have this a upon r की power 2n plus 1, and then again you have this p 2n plus 1 cos theta, and अंदर वाले braces में this 2 से 2 common out cancel हो गया, तो this is 2 की power 2n. So this is how you're going to express your potential for a linear octupole arrangement at any distance r. And what do you see? What do you see that the leading term, if you see, if you place n equal to 0 here, so this will become 1. So your leading term, एक मिनट देखते हैं इसको, लीडिंग टर्म कैसे पकड़ेंगे, यहाँ कुछ गलती करी हम क्या? लीनियर क्वाड्रुपल अरेंजमेंट में जो लीडिंग टर्म था हमारा, that was dependent on
R की पावर 4
1 upon r का क्या बोलते हैं, पीछे देखते हैं जो नहीं है, तो r क्यूब था. ओके ओके, एक मिनट तो
यहाँ पे आपके पास
क्या गलती कर रहे हैं, क्या गलती कर रहे हैं, लेट मी सी, लेट मी सी, लेट मी सी. यहाँ तक तो सब कुछ सही है, राइट? सो हमने क्या किया होगा, लेट अस सी, लेट अस सी. अच्छा ओके, सो इफ यू टेक n equal to 0, right? If I take n equal to 0, so if I take n equal to 0, this will become 1 minus 1 0, right? So I'll write here, for n equal to 0, potential Vp would be 0. So effectively, I have to start this calculation from n equal to 1, right? I will have to start this, because anyway, if you start from 0, so this will become 0. So there's no point writing n equal to 0. So from n equal to 1 only, the calculation would start, and I would get that my potential is directly proportional to 1 upon r की power 4. Is that clear or not clear till now? I hope the leading terms are now clear.
Yes, sir.
So in other words, if you see the Griffith book also, the edition that I have, you'll see there is a diagram. I don't know which page it was, but I clearly remember that there was a diagram. I'll make that diagram and just referencing it is there in, I think, Griffith. So Griffith says that the monopole, he just justifies it because that is obviously an undergrad book. So he's not going to derive all these things. So he says that potential is directly proportional to 1 over r if there is only a single charge. If there are two charges equal and opposite, that is, if I write minus and plus here, this constitutes something called as your dipole, and here your potential is inversely proportional to 1 over r square. If you have this quadrupole arrangement, then what will happen? In quadrupole arrangement, you have, let's say this is your quadrupole arrangement, that is negative, positive. This is what he has made. However, we have done something like, so in this quadrupole arrangement also you can see there are like dipoles. This dipole is in this direction. This dipole is in this direction. Dipole moment, sorry. Dipole moment here is there, and here it is here. So there are opposing dipole moments. So here you have this kind of thing, and in these two things you have this kind of thing. So you have opposing dipoles. This kind of arrangement is also called as a quadrupole only. However, we have discussed our linear quadrupole system. So in this quadrupole system, your potential is inversely proportional to, we have got r cube, and in octupole arrangement, where we have equal and opposite charges on the adjacent side, on the like neighboring ones. Like for example, if I write plus here, so it will be negative here. If I have written plus here, so negative will be here. If I have written negative here, it will be positive. It is negative, it is positive. This is positive, then this is negative. This is positive, this is negative. So this is an octupole arrangement. And in this octupole arrangement, for the linear case, we have actually derived that the leading term will be inversely proportional to r की power 4. So I'll write all these things as a Just now, these things as leading behavior. So I'll write leading behavior. Okay, so this is your leading behavior. Okay, is that clear?
Yes, sir.
Take note, huh? Okay, so this sums up our discussion. So overall, understand. So all these things are very important. I would suggest that at least if you can, if you're so for example on the very first day also I told you ना कि जैसे legendary polynomial का सबसे ज्यादा इस्तेमाल मतलब हम कहाँ करेंगे? Mostly we'll use it in the case of uh, whenever we have this Newtonian potential. So we have to write a Newtonian potential for inverse square law of forces. So wherever there is an inverse square law of force, the potential would depend as 1 over r, and that 1 over r when expressed in form of some law of cosines. So you'll get this kind of behavior, this kind of thing. Right? Whatever we have done right now. Okay, so we know that eventually this particular thing is very important, and so you can do that if the potential is inversely proportional to 1 over r, electric field will be proportional to 1 over r square. You know that because this is del v upon del r, and then this will be proportional to 1 over r ki power 4 here. Electric field here would be proportional to 1 upon r ki power 4. Sorry, r ki power 4 here, and this would be r ki power 3 here. Sorry, and here electric field would be proportional to 1 over r ki power 5. Is that clear? So this is something that one needs to remember. Mostly what happens in exam, they will give you a question where you can have certain hint about dipole, that if dipole moment is coming out to be 0 or not. However, understand that quadrupole moment is in general a tensor quantity. It is in general a tensor quantity. So probably this is something that they may not ask. However, I'm going to write a few quadrupole moments for you, but mostly concentrate on dipole for exam per se. And otherwise, I'll do a few questions on quadrupole as well. But in general, remember that quadrupole moment is a tensorial quantity. So this is quite difficult for an examiner to set a problem in exam. So mostly you'll find that questions are asked on dipole and all those things. So in Legende's polynomial, since I'm doing this, I will I'll extend this discussion in electrostatics now. But let us do another case because there is still time. So in general, what we have come to understand, we've come to understand that what I can do is I can meanwhile help you understand a few more things. So just try to recognize one concept, and that concept is called as your point dipole. So that is called as your point dipole because now next lecture will be on multiple expansion. That will be more on electrostatics. So right. So what is a point dipole? So point dipole is an idealization where we are actually taking the distance between the two charges as small as possible. So point dipole, let us say the strength of the point dipole is again denoted by P only. So let us say that the strength is denoted by P, and it is one of the so you can say that it is placed at z equals to let's say I'll write a plus del, and there's another minus P which is placed at a minus del. So instead of now charges, I'm writing dipole moment strength here. So instead of charge, it is given that point dipole मतलब समझ रहे हो मतलब now you do not have like you have this kind of thing, q and minus q is only there, and this distance is a is there, but this distance a is tending to 0. So what I'll as small as possible. Is that clear? So now one dipole is kept at a plus del, and this dipole would comprise of like both of these charges, but this is very small. So this can be written as a point dipole. So one point dipole is placed at z equal to a plus del, and another point dipole is placed at a minus del. Is that clear? कहाँ चले गए सारे बच्चे?
Yes, sir, sir.
Or should I
Sir, in
repeat?
this case, the magnitude of Q have to be small, no?
Its magnitude would be too small, right? Because हो क्या रहा है generally this if you read Griffith would say it as physical dipole and a point dipole. So physical dipole, by which he means that there is some distance that you can take for like you can take account for. And in this case, what I'm saying is, in this case, I'm saying that ये ऐसे समझ लो, चलो मैं ऐसे नहीं समझा रहा तुम्हें, ऐसे समझाता हूँ. लेट अस से तुम्हें ऐसे नहीं समझ में आ रहा तो ऐसे समझो पॉइंट डायपोल को. सो ऐसे नहीं समझ में आ पा रहे हो तो कोई बात नहीं, कंफ्यूजन ना क्रिएट हो जाए तुम्हारे लिए. पॉइंट डायपोल समझाता हूँ. सो लिख लो इसको एक सेकंड. सो पॉइंट डायपोल, so I'll write a point dipole is generated by what I can say two equal and opposite charges, equal and opposite charges separated by मान लेते हैं डिस्टेंस सम डेल मान लेते हैं, ठीक है, सेपरेटेड बाय अ डिस्टेंस डेल वेयर डेल टेंड्स टू 0. ठीक है, ये समझ में आ गया अब तो, ठीक है. सो पॉइंट डायपोल उसको कहेंगे. पॉइंट डायपोल किसको कहेंगे कि जैसे मान लेते हैं यहाँ एक चार्ज है और यहाँ एक चार्ज है. जनरली हम लोग क्या ले रहे थे, इस डिस्टेंस को ना बहुत ज्यादा ले रहे थे, याद करो. अगर इस डिस्टेंस को मैं बहुत कम कर दूं, मतलब एज स्मॉल एज पॉसिबल कर दूं, देन इट वुड बी फाइन, इजंट इट? सो लेट अस टेक फॉर कन्वीनियंस ऐसा समझ लेते हैं कि लेट अस से दिस इज ओरिजिन, या फिर ऐसे समझ लेते हैं दिस इज सम पॉइंट ए. ये मान लेते ए प्लस डेल पे है और इसको मान लेते ए माइनस डेल. कोई दिक्कत? तो इनके बीच का डिफरेंस क्या है, टू डेल. और डेल टेंस टू जीरो तो टू डेल भी टेंस टू जीरो हो जाएगा. इज दैट क्लियर?
Yes, sir.
So now let us try to find the potential. Now let us try to find the potential at any distance r from the origin. So instead of origin, I have kept it as, मतलब मान लेते हैं कि डिस्टेंस पॉइंट ए है जहां से हम लोग इस चीज को रेफर करते हैं. इज दैट क्लियर, नॉट क्लियर?
Yes, sir. Sir, मैं तो ये बोल रहा मैग्नीट्यूड चार्ज का भी कम होगा ना?
मैग्नीट्यूड चार्ज का भी क्या होगा, सॉरी?
कम होना चाहिए ना सर?
हाँ, राइट. अदरवाइज वही प्रॉब्लम्स आ सकती है. जैसे फॉर एग्जांपल दिस इज वेट अटैक. तुम किस सेंस में कह रहे हो चार्ज का कम होना चाहिए?
मतलब मैं इस सेंस में कह रहा हूँ सर, अपोजिट चार्ज है तो वी कैन नॉट ब्रिंग देम टू क्लोज
हाँ,
बिकॉज
राइट,
रिपल्सिव फोर्स रहेगी.
राइट, राइट. I mean, these are all idealizations, right? These are all idealizations. और होता भी है. For example, you see molecules और इस तरीके की चीजें हम जब देखते हैं तो we'll see like these kind of things do exist.
यस सर.
हाँ जी.
हाँ जी सर. मतलब इसका डेल का कोई वो भी है क्या सर? मतलब अ, जैसे कितनी कुछ माइक्रोमीटर्स या कुछ ऐसे डिस्टेंस,
यार
वो तो
नो
हमने
आइडिया,
डिफाइन कर
राइट नाउ
सकते?
नो आइडिया, राइट नाउ नो आइडिया. अभी मेरे को कोई आइडिया नहीं इसका. तो आई एम लाइक जस्ट ड्राइंग, जस्ट मेकिंग लाइक एक तरीके का पॉइंट डायपोल. लेट अस स्टडी इट इन मैथमेटिकल सेंस फर्स्ट.
ओके सर, ओके.
I'll see all those things कि इसकी क्या फिजिकलिटीज होनी चाहिए और क्या नहीं होनी चाहिए. लेट अस सी दैट आल्सो बट लेटर ऑन. बट अभी के लिए ऐसा समझ लेते हैं कि हम लोग एक पॉइंट डायपोल देखने की कोशिश कर रहे हैं. एंड दैट पॉइंट डायपोल वी वांट टू फाइंड पोटेंशियल एट एनी डिस्टेंस, लेट्स से एट आर. ठीक है. सो मान लेते हैं ये आर डिस्टेंस दूर चला गया, तो ये आर होगा. ये मान लेते थीटा है. ये यहाँ से यहाँ तक कितनी डिस्टेंस हो गई. एक काम करते हैं ना, इसको ओरिजिन से ही ले लेते हैं, माता जी का. सो मान लेते हैं कि ऐसे पकड़ के चलो इसको, कि जैसे कि इसको इजी रखते हैं, इसको ओरिजिन रखते हैं. तो फिर इसका ए का क्या करूंगा मैं? ठीक है. सो लेट अस टेक दिस एज ओरिजिन. इस डिस्टेंस को मान लिया ए प्लस डेल, इस डिस्टेंस को मान लो ए माइनस डेल. लाइफ इजी. नहीं तो फिर उसके अंदर मेरे को आर माइनस ए और लिखना है ना, क्योंकि फिर उसका पोजीशन वेक्टर चेंज हो जाएगा. बिकॉज इसका ओरिजिन के रेस्पेक्ट में ए हुआ तो फिर इसका हो जाएगा. समझ पा रहे हो ना मेरी बात? तो इससे अच्छा इसको वही ले लो, इसको ओरिजिन लेते हैं. मैं बस तुम्हें एक चीज सिखाना चाह रहा हूँ, कुछ नहीं. सो लेट अस कंसिडर द पोटेंशियल एट एनी डिस्टेंस r फ्रॉम o फॉर द गिवन अरेंजमेंट. ऐसा समझ लेते हैं कोई गिवन अरेंजमेंट. and let's say this is your point P. So we want to find potential at point P. So potential at point P would be equals to what? It would be equals to, again, KQ upon, I'll write here, 1 over R कितना होगा? 1 plus, यहाँ पे लिख देंगे, R plus A plus del का whole square. Here also I'll write A R square, and this will be minus 2A plus del, and then there would be R, and then there would be cos theta, and there would be a 1 over half, and then minus K, sorry, this will be 1 upon root over R square, and then A minus del का whole square, and then minus A minus del, and then R, and then cosine theta. Is that clear? Sorry, ये plus हो जाएगा, because this is theta, this will be pi minus theta. Is that clear? यहाँ तक कोई दिक्कत तो नहीं. So हम देखेंगे कि almost देखते क्या expression आता है, ठीक है? So let us say this VP will be given by KQ upon R. इसमें से root common लेंगे, तो पहला वाला term क्या बन जाएगा? It will be simply, I think I'll write it as summation A plus del upon R की power n लिख देते हैं, और इसको लिख देते हैं Pn cos theta. Is that clear? समझ में आ रहा है? क्या कहते हैं? Actually,
Yes, sir.
I'm not able. I did not actually define it very nicely, but जो एक बार मैं समझाने की कोशिश कर रहा हूँ कि इन दोनों के बीच का डिस्टेंस जितने छोटे से छोटा लेने से उतने छोटे से छोटा ले सकते, तो that is what I have done. So summation, and I'll write here from n equal to 0 to infinity, I'll write A minus del upon R की whole power n, and then you have this Pn cos theta. Is that clear?
Yes,
Okay.
sir.
Okay, I think it is fine. Now, in the limit del tends to 0, in the limit del tends to 0, what you can do, यहाँ तो एक काम करते हैं, what I'll do is, I'll simply take this VP, I'll write KQ upon R here only, and P and cos theta तो ठीक है. What I'll simply take this A upon R common out. So if I take A upon R common out, so I'll take A upon R, and then I have 1 plus, I think this would be del over A, isn't it? So this is del over A, and this will be n all over, and then minus summation. Again, I'll take A upon R common here. So I'll get 1 minus del upon A raised to power n, and then I'll take this common bracket and I'll write P in cos theta. Is that clear?
Yes, sir.
Okay. And also you can see that at n equal to 0, this will be, I think, 1. जैसा पहले हुआ था वो वाली गलती ना हो जाए. Because at n equal to 0, this would be 1, this would be 1, so I'll start from at least 1. ठीक है? Is that clear? मतलब पहले जो हमने गलती करी वो ना हो जाए. Exactly.
Yes, sir.
Is that clear? So now my potential at P would be equals to KQ upon small r. And what should I do? I'll take a binomial expansion from here. I know that your del is very, very less than A, because after all, you know, this is del was tending to 0, isn't it? So if I do that thing, then summation n equals to 1 to infinity, I'll get A over A upon R ki power n, and I'll simply write 1 plus n del upon A, and then minus A upon R ki whole power n, and then you have this 1 minus n del upon A. Is that clear? And P and cos theta. I have taken मतलब इस summation को एक साथ ही लिख दिया, so that मतलब दो बार लिखने की जरूरत ना पड़े, because the terms are similar, right? So now this is VP. I will write simply KQ upon R, and this would be, if I take A upon R common out, so what I'll get, it will be like n equal to 0 to infinity. I'll write A upon R raised to power n, and I think this would be 2 times, and I will write n, I will write del, and I will write upon A, and then I will write P and cos theta. Okay, so effectively, if I take this, I don't know what to do about this L. Let's say we'll do something of this L. So this A would come out. So I'll write VP as Q upon 4 pi epsilon naught R into A, and this 2 del will come here. So I'll write 2 del here, and then I have this summation. There would be indeed n remaining there. So I'll let n remain there. There would be n equal to 0 to infinity. N would remain here only. And there is a upon r की power n, and this is p n cos theta. Is that clear? And you know that q into 2 del, what it will be? I think this will be dipole moment. See,
yes,
dipole moment का क्या होता है? Dipole moment में you multiply the charge by the separation between them. So the separation between them is given by 2 del, isn't it? The separation between them is given by 2 del. So your dipole moment is given by q into 2 times del. Is that clear or not clear? Right?
yes sir.
ये समझ में आया नहीं है?
हाँ भैया।
ओके ओके, सो इसको एक काम करते हैं, इसको लिखने की कोशिश करते हैं. सो व्हाट आई विल गेट इज, आ गया ये सारा टर्म. सो आई विल राइट इट हियर. सो योर पोटेंशियल एट P is given by P upon 4 pi epsilon naught R A sums n equal to 0 नहीं, n equal to शायद 1 था, n equal to 1 है ना, n equal to 1 कर दिया था हमने, राइट? क्योंकि बाकी सारे टर्म कैंसिल हो जाएंगे n equal to 0 पे. n equal to 0 पे मतलब 1 minus 1 0 हो जाएगा. So n a upon r raised to power n, and then I have p n cos theta. So this is the idealization which is called as your point dipole. Well, I didn't, मतलब मुझे इसको थोड़ा ढंग से समझा लेना था. I should have defined the problem very well, but this is what I could do. So actually I was not, I just thought कि इसको एक बार ऐसे करके देखते. So I don't know मतलब what will be the, like whatever Bharat is asking is he's writing his own capacity, but right now I'm not aware of what distances del would be and what q would be for the correct physical consideration for this to remain intact or stable, whatsoever he means to say, because he means to say that what should be del and what should be the magnitudes of q so that this kind of setup remains alive. Okay, so this is what he has to say. I am not very certainly very sure ki, do I even remember some kind of a physical counterpart to give some kind of an idea. So right now I'm not aware. So right now I've just taken this problem or just written this problem for the sake of doing some sort of mathematics here. Okay, okay, is that clear? What we can do, for instance, we can try to find what would be the leading term behavior. So what would be the leading term behavior? This is quite certain that leading term behavior would be given by n equals to 1. And if you take n equals to 1, the potential P will come out as, I think, the same. It will be P cos theta, because n equals to 1. This will be A by R, A cancel, R will be. So it will come out as P cos theta. I think it should be divided by 4 pi epsilon naught R square. Is that clear?
yes sir. सर इसमें डिफरेंस क्या है अपने नॉर्मल डायपोल और पॉइंट
कोई
डायपोल
डिफरेंस नहीं, कोई डिफरेंस नहीं है. सिर्फ बस इतना सा है कि पोटेंशियल तो सेम. आई थॉट कि why not take this case, but however potential to same ही आ रहा है. Potential is not even changing. Like potential यही तो आ रहा था हमारा पहले भी, right?
हाँ जी सर.
So I don't know, मतलब इसके अलावा I thought कि just let us construct this problem. So I constructed this problem called as point dipole, and this is what I have done. Is that clear? Not clear?
yes sir.
Okay. So अभी इसके बाद let us try to do some, क्या कह सकते हैं, some things on some bit more on multiple expansion. So I'll join you in the next meeting. Okay, is that clear? So देखते हैं. I'll just see to your inquiry also. मेरे पास देखने दो इसको. But otherwise, I thought कि it would be nice to take this thing, but eventually we landed up getting the same result. Okay, so we landed up getting the same result only. What I can like, this is what I've got till now. Is that clear?
हाँ जी सर.
हाँ भैया.
Okay जी, चलो मिलते हैं.